Hello class. In this video we are going to discuss the something called the TukeyHSD. TukeyHSD is what we call honestly significance difference. So this is when we test the one-way ANOVA, and the null hypothesis is that we are assuming that all three means are the same. So let me just go there. Okay. So here, the null hypothesis. Oh, wait a minute. That's not what I want. I want pencil. Okay, so that's too small, isn't it? Hang on. Size. Let me use that one. Okay, so what I have here is that null hypothesis. Okay, we're assuming that that's going to be mu1 equals 2, mu2 equals 2, mu3. So that was our null hypothesis. Now, if you fail to reject the null hypothesis, then we all know that those three means are the same. In other words, that we collect some of the samples from each population, and then if your sample indicates that you failed to reject, that means that mu1, mu2, and mu3, they all have same means. It is the case that we are interested in when you reject the null hypothesis. So when you reject the null hypothesis, the alternative hypothesis is going to be at least one is different. Okay, at least one mean is different. Okay, so when you reject the null hypothesis, then we are assuming that H1 is true. So at least one of them is going to be different. So now the natural question is, okay, which one? Okay, and that's the one we are using for something called TukeyHSD. Now there's one restrictions on the TukeyHSD, that is that each sample must have the same sample size, meaning that if you look at these four samples that I put them up here, okay, so one is a placebo, the other one is a drug A. I don't want to cover this. Never mind. Okay. Maybe I can go back, can undo this. Hang on. Okay. All right. Maybe that's better. So here we have a placebo. Hang on. Okay, so we have a placebo here. Okay, color. And then we have a drug A and drug B and drug C. So if you look at each sample, we have 5 items in there. So that's a requirement for using TukeyHSD. Okay. So what we want to do now is that we want to use this TukeyHSD to find out which mean is the difference. So in other words, that we have a placebo is going to go up against a drug A, B, and C. Then we're going to do the same thing for drug A, B, AC, and drug B and C. So in order to do that, we have to find something called HSD. That's the numerical value that you need to find. Okay. So if you look at the HSD, there is something called the Q values here. So that's the student Q values that we need to find. Okay. So if you go to your table, I'm not going to upload the table here, but if you look at the table, the Q table that is, okay, I'm going to show you here. Okay, I'm going to show you, where's my thing here, come on. Okay, so if you go to the Q table, you will see that. Okay, so each column here is called the K, number of sample K. Okay, small k, that would be the, how many samples you have. So in this case, we got 4. So that means you're going to have to go to the fourth column here. That's 4. Okay. Now the rows that we are talking about is called the degrees of freedom error here. So if you go there, it will say the degrees of freedom, okay, the error. So if you look at my, where am I? If you look at my statistic output here, okay, so you will see that degrees of freedom error, that's going to be the 16, right? So you're going to have to go, that's the degrees of freedom within there, okay? So we're going to have to find the, what's the value there. So you have to go down to, I'm just going to go down here. Let me use this guy here. Okay, so over here, much better. And the degrees of freedom, that's the degrees of from within. Now that's the same as the this guy over here, 16. Degrees of freedom is 16. And we need to find the value in this box there. So if you go there in box, and you will see that the box tells you that it is going to be 4.05. So you got 4.05. Okay? So that's going to be our Q value there. So we're going to find, okay, so HSD now is going to be, Q is going to be 4.05, and then we're going to have to put the square root. So you got MS within. The X bar means that that's supposed to be M. So MS within. So in this case, we're going to have to look at the on the column called MS. Now remember, the arrow is the same as within. Okay. So MS within, you will see that you got 2 there. So on the MS within, we're going to go and put 2 on the up there. 2. Then the n is going to be number, small n is the number of items you have in each sample. That would be 5, right? So we're going to put 5 in there. Okay, so now we're going to take the, so that becomes what, 4.05. Then this comes out to be 2 divided by 5, you got 0.4. Okay, and if you multiply this, okay, you will get something called HSD value. So I get about 2.56. Okay, so in this case I get 2.56. Oops. Okay, now once we find the HSD, the next thing that we're going to have to do is we're going to have to compare head to head of the mean value of each. So X placebo minus mean values of A. Now remember, this is the absolute value now. And then we're going to do placebo against drug B. Oh, stop. Let me, okay. All right, so the next one is going to be the placebo against the drug C. Then we have a placebo against the drug D. Oh, sorry. I finished that, right? So let me just go back and read. Okay, so then I have drug A go against the drug B, then drug A against the drug C, then finally drug B against the drug C. So that's what we need to do here now. I already found the mean for each sample here. So let me go back. I don't have that here. This is just the one-way ANOVA output. So now I'm going to go back and find out what that was. So the placebo was mean of 1. I'm just going to write that over here. Let me use a different color here. So I'm going to use, okay. So I'm just going to write it up here. X bar placebo was 1. X bar A, X bar B, and X bar C. So let's just go back in the A, B, C and find out what I found here. So A was, mean for A was a 2. So I'm going to write that up here. Oh, where are we? Okay. We still have a blue, right? So we have, this one's 2. And the B and C, I have what? B is 4, and the C is 5. So that would be 4 and 5. So I'm going to write that over here, 4 and 5. So what we're doing here is that we're going to compare these here. So for example, placebo against A, drug A would be 1 minus 2, an absolute value of that 1. So since the 1 is less than 2.56, this is no significant difference between these two drugs. So what the Tukey's HSD is saying is that whatever you found HSD, you're going to then compare this value after you find the difference between the two items head to head. If that's going to be greater than 2.56 of the HSD, then there's a significant difference between these two elements. If it's going to be less than 2.56, then there's no significant difference. Okay? So that's what we're doing here. So now again, and the placebo and the drug B, which is a 4, and there will be a 3, which is a greater than 2.56. That's a significant difference. Okay. And then the placebo and drug C. And again, you got 1 minus 5, which is a 4. And that's greater than 2.56. And this is also significantly different. Okay. Now let's just go to the A and B. So that means you got 2 minus 4 equals to 2, which is less than 2.56. And between drug A and B, there is no significant difference. Now between drug A and C, we got 2 and 5. 2 minus 5, which is a 3. And that's greater than 2.56. So we can see that there's a difference, significant difference between the drug A and C. And finally, drug B and C, which is what, 4 minus 5. Okay. And that's equal to 1, which is less than 2.56. So no significant difference there. Now, if you look at the these results over here, and you can see that when you do the calculations, you know, the placebo and drug A is there's no significant difference, but you know, placebo, between placebo and drug B, drug C, and between the drug A and C, they are significantly different. No. So what we're saying here is that, you know, even though, you know, when you look at the placebo drug A, B, and C, the Tukey's HSD requires that you go head to head from one item, one sample to the other sample and see if there's any significant difference. It does not tell you that when you look at the placebo drug A and B and C, then you compare all 4 at the same time, it's not going to tell you that. So Tukey's HSD, you must go against head-to-head. Then when you go head-to-head, then find the difference of those two means and compare that to HSD. Then you will be fine, see if there is any significant difference. Okay, if they are greater than, okay, greater than HSD. Okay, so that's the what we call the Tukey's HSD. Now there are other ones that we can use, but in this class we're just going to focus on the Tukey's HSD only. All right. Thanks for coming, and I'll see you next time. Okay. Bye bye.